On this episode of Office Spaces, we're hitting the road in search of the latest in lighting and air technology, getting up close and personal with the future of facades, and solving one of the biggest problems in construction today. Coming up now on Office Spaces. Now join us on a trip to the Lone Star State for a virtual view of the future and the technology driving it. Witness a revolutionary leap forward that is redefining comfort zones.
Welcome to Titus.
Titus is an industry-leading HVAC company. They're continually innovating in every aspect of air distribution technology, from regulating airflow to advancing designs in air diffusers and everything in between.
Titus is an air distribution company that's been around for about 70 years. When you look back at the products that we have brought to the marketplace over the last probably 10 to 15 years, they have set the foundation for what we're bringing to the market today. So one of the great things at Titus is that we have a very, very strong network of engineers, architects, experts in the field. They've been there for decades. They know what is going on. That helps us staying at the forefront of ideas, and that allows us to co-develop products like the ventless locks.
Paul Wolford is a design principal at HOK, a global design, architecture, and engineering planning firm, and the brains behind Titus's newest innovation, the Ventus Lux chilled beam system.
In a chilled beam system, the air is coming through and it's cooled on the spot of being dispensed into the space. So Ventus Lux was really born out of the challenge of how do we create a solution in which you have all of these different infrastructures in a typical ceiling. So often if you walk into a space, you might not be that cognizant of it, but as a designer, we are. We look up and we see light fixtures, we see different kinds of displays, we see air conveyance devices, and instead of them all working together, each of them is designed and put in by someone else. And so what we did is we looked to consolidate and reduce all of those different situations into a single solution, and that's Ventus Lux. In our practice, we have multidisciplines. So architects, interior designers, landscape architects, and engineers all sit together to solve the problems that we face. We look to lessons beyond what we've done every single day. And in this situation, we actually look to Titus as our partners.
Titus is not only at the forefront of air diffusing and chilled beam technology, but on the leading edge of training too.
Product innovation is important to us, but we also need to think about how can we interest consulting engineers as well as contractors to come to Titus to see our products, to see what we have to offer them.
People have shorter attention in general these days, and they expect more out of training. So one of the things we did is the 3D wall behind me. So we control it off of this pad, and it allows us to walk them through training in a way that they can actually see it. We also have VR goggles. It's a way to get the next generation interested. It's nice to be able to see where the product is installed, how different parts of the system go together. It's actually an immersive situation where you put it on and you can actually look around the space and you feel like you're in the space. This allows us to do it here, everybody get an idea of what they're going to see, and then take them out in the lab for the hands-on part.
Investing in testing is something that Titus takes seriously.
The chilled beam testing chamber is one of 2 in North America. It gives us the amazing ability to do some testing that no one else can do to get really good performance data for our products. David, so you want to talk about what we're doing today?
Absolutely. Well, Roger and I were getting ready to set up for a chilled beam test. We used the chilled beam testing chamber to test chilled beam capacity. Measuring performance has to be tightly controlled. This chamber allows us to do this. Let's take a look inside. So as we come in the chamber, you'll notice a couple of different things that are very important. One of these is going to be our test apparatus here. What we've got set up here is to measure airflow, induced air across the chilled beam. One of the other things we have here is we have our heat dummies. What these dummies are meant to do is they're meant to emulate actually people, so that we're constantly maintaining a set temperature inside the space. We're also trying to maintain a temperature in here without producing any heat plumes that will affect the induction that we'd see inside the chilled beam. We're going to be doing a smoke isobel test on the Ventus Lux. We want to make sure that we're getting sealing adherence from the air coming out of the unit. As we see the smoke, it's going to start generating in the air handler, and it'll come out of the air slot, and we're going to form a negative pocket right along the edge of the diffuser. As it does that, it's going to pull the smoke along the ceiling. Now you can see the air coming along, and as some of the air is starting to return with the smoke, you can see it start to turn back, pull back into the airstream, and get carried again down along the ceiling. As they induce that air, we get a lot of turnover, and we get, for that reason, a very consistent temperature throughout the entire space.
Titus has proven that an effective light and air diffuser can be attractive. So now it's time to see how their Helios diffuser is also redefining their end users' comfort zones. Today, we're visiting TD Industries, a mechanical engineering manufacturing facility. At TD Industries, they know a happy employee is a productive one too. So when coworkers Ryan and Jetsy had a difference of opinion over the office temperature,
I love it working here. It's just that I'm usually cold all the time.
their supervisor Justin stepped in.
The issue here was that Ryan always liked it cold in his office, and Jetsy next door shared a thermostat, and she liked it warmer. And so that was an opportunity to have an innovative product to help solve that problem.
What Ryan and Jetsy need is a wireless diffuser that will deliver the right amount of cool or warm air without a thermostat.
Hello, how's it going?
Hi, Fred, how are you?
Good. Ready for a new diffuser install?
Yes, I'm super excited.
Great. So we're looking at the installation of the Helios diffuser. And because it's a smart device, before you install the diffusers, there's a few things you need to do prior to installing. So we'll pop the cover. There's two dials here. One is for heating, one is for cooling, and you'll set the dial based on the temperature on the chart here that's referenced here. Also, we have the wireless thermostat version. You will move the wireless antenna out here, close the cap, and the product's ready for installation. The way the diffuser operates, it has a solar panel mounted on the face, which is capturing ambient light in the space. The diffuser wakes up every 10 minutes to sense temperature in the room, and it will reduce or increase the amount of air being delivered to the occupants, and that's how it's controlling temperature. It's no different from any other diffuser install, except it's just a smarter device.
Hey, Trent, can you pass me the grill, please?
Yeah, you got it.
Helios is wireless for simplicity, light-powered for economy, and digitally logical for accuracy. Titus's investments in innovation and their ability to stay one step ahead can only mean one thing.
If we're going to go to market with something that takes all of the confusion out of all those disparate devices and infrastructure and space and come in with something that's so beautiful and streamlined, well, it better be darn remarkable.
The future of design is now. Rhode Island, home to some of the most beautiful and historical architecture in America. Now meet the people who are revolutionizing this age-old facade.
This is the story of a brick. Brick is beautiful, and brick has been around for centuries. The heaviness of brick and having to put that on the outside of a building as a veneer becomes very, very complicated. It's very, very costly to build an energy-efficient brick building. Unfortunately, brick hasn't changed, but the way we build buildings has changed.
Clay brick's great once it's finished, but the whole process, transporting it, getting it on site, moving it, laying down the mortar, making corrections, if there's ever a problem, having to cut them. A lot of things can go wrong in the entire construction process.
In the brick business, the fastest growing part of the brick industry is thin brick. Brick's trying to get thinner. It's trying to get more lightweight, but it's still rigid, it's still heavy, and it still really doesn't have a place with the way we build buildings today.
So when a breakthrough idea was presented to the folks at Drive It, they knew it was going to be a game changer.
I said, what do you think? And he goes, wow, how come I haven't seen this before? I knew right then that we had something that was pretty attractive to the market.
It's one of those things you look at and you say, wow, it's so simple. Why didn't someone think of this?
I tried to understand how could we emulate brick? How could we make something that looks traditional but has the energy efficiency that is unheard of? So this is new brick. It's been in the works for about a little over 5 years now, and it's now part of Drive It's leap forward in the innovation and revolutionary new products. There's several problems in the construction industry, right? One is speed, and the other is ease of use. This brick takes care of those problems. This alignment guide is for speed. It creates its own horizontal joint, and it allows the brick to be stacked.
That lip, that patented lip, is really an important feature of that new brick. And it really is what is going to make the installer see the beauty of new brick, because he's going to install more brick in one day than he could ever install a clay brick.
So with clay brick, because you're using a lot of mortar, it's a lot of weight, eventually you have to stop to allow it to cure, usually waiting a whole nother day. With new brick, that's just not the case. You can just go as high as you can, as far as you can, with as much as you have.
Brick is held together by fire, and new brick is held together by chemistry.
find out more about new brick, we're heading to the factory to see how it's made. The raw material is made with an XPS foam board.
When the sheets come in, they look like that. They come in pallets and then go to a next step of cutting each one of them to stick length.
Extremely hot wires cut the sheets into sticks.
A pallet of extruded XPS will make 1,800 bricks.
The sticks then get their lip, or patented alignment guide, and it's off to the meshing station.
After identifying each one of the sticks with our patent number, we go into a meshing operation. The meshing provides strength to our stick and eventually puncture resistance to each one of the bricks. Our next step in the operation is the base coating of the sticks.
When it comes to options and custom colors, New Brick's versatility gives architects the design freedom they never had before.
We have standard colors, textures, and finishes, but we can go beyond that. As long as we know what that customer need is, we can create that and develop that.
We received this sample from a potential customer. We go through the process of first matching for color, matching for texture, and after that process is done, we provide the sample to the customer that is a perfect match. After each one of the sticks has been dried with a finish coating, they go into our final cutting operation where each brick is cut to length. Follow me, I'll show you. We are now in our cutting station where we'll be cutting sticks into individual bricks. Each of our sticks will provide 6 bricks, and the operation takes about 5 seconds. Our final operation in the shipping department is palletizing. There is 6,000 bricks on this pallet alone, and then we're going to be doing shrink wrapping, and it'll be ready to ship.
Now the astonishingly lightweight pallets will be shipped and ready for install.
You know, what will be different with this versus conventional brick is, the fact that it's so lightweight, they can just carry this up the scaffold themselves, just bring it up in bundles. Each bundle has about 90 bricks. They don't need to have special scaffoldings to account for the weight of the conventional brick. So it just makes the whole process a lot easier. It's certainly a lot more ergonomic because it's not as physical as installing conventional brick.
The application is very easy. It's extremely light, where we were able to lay about 200 bricks in about 20 minutes.
It's not only lightweight, but extremely durable.
One of the great things in modern day materials science is that you can see that the materials you choose affect the properties that you will see in a product. So one of the things we do here is we test things like impact resistance. So we have an instrument here that allows us to drop a set weight onto a material that we've created and allows us to see how it responds to that impact. I'm going to place the brick under this surface, and then it allows me to pick up the weight to a set distance. This is going to be equivalent to about 48 pounds per inch. And if I drop that, then we are able to see that the brick has no significant damage or cracking or breaking to its integrity. Now in comparison, if I show you a thin brick, I can take the exact same test apparatus, I place it under there, now if I lift it to that same amount of force and drop it on there, when we drop that, we can see that the material is brittle and will crack due to the nature of the clay material.
Prior to new brick, it was really difficult to, let's just take renovation as one example. It was really, really difficult to renovate a construction or a building that was already existing with clay brick.
If a clay brick breaks, it's a little challenging having to cut in, remove the old mortar, fit a piece in, remortar it. It's more time consuming than you would think.
Today, we have the ability to match how that brick looks on an existing building through our customization capabilities here at our new brick facility. So we have a team of folks who literally will take the existing bricks that come in and they will make our new brick look exactly like those bricks, so that when you renovate that building, you don't even know the difference. It just looks completely seamless.
Today we're making so many different textures, so many different colors, different variations, different shapes. These are all things that brick just simply can't do. With new brick, the owner's a winner because he gets an energy efficient building, he gets the look of brick, and that's really what he wanted. It's great for the architect because he can design a building much more easily. And then the general contractor, of course, can now construct a building, and he can do it in a timely manner, and he can get it done within budget. So whenever you can find a way that you can get more done with less people, it's a winner.
Welcome to Milwaukee, Wisconsin, home to Marquette University, where students can study and play in the heart of a dynamic city. To keep up with their booming population, the university is building more student housing, and they're doing it faster with the help of two innovative companies, USG and Tremco. USG is a long-standing player in the commercial construction world, with the goal of making high-performance products that make better buildings. The experts at USG and Tremco realize they can save contractors time and money by combining two of their existing products. So what happens when you combine these two systems? You get SecureRock ExoAir 430.
USG is an expert at developing glass mat sheeting products for the exterior of a building. Tremco is expert at developing liquid applied membranes for the air-water barrier system.
SecureRock ExoAir 430 is a non-combustible, glass mat-faced, moisture and mold-resistant gypsum panel with a factory-applied membrane. It maximizes the control of air and water into a building.
Essentially, an air barrier is just a jacket for your building, right? So it's the inner structure of your jacket, because you don't visually see it. It goes on that backup wall, it gets covered with insulation and your exterior facade. This is the SecureRock ExoAir 430 panel. Tremco manufactured this orange membrane. We took a fluid that Tremco already manufactured, we took the board that USG already manufactured, and we just changed where it was made. So we made it in a factory setting at a controlled thickness.
We combined those two ideas into one integrated system, which is now our SecureRock ExoAir 430. It's about keeping the weather outside the building and the energy inside the building, but it gives our contractor customers a great solution to simplify and speed up the construction process.
By combining the two at the factory, they're changing the way contractors build while also speeding up the construction process.
The reduction or the availability of skilled labor, that's a big issue right now. So we need to create products and solutions and systems that are really easier to install. SecureRock ExoAir 430 is a great example of that. We're taking two steps, putting them together in a factory-installed environment, and essentially eliminating a step in the field.
USG and Tremco are making energy-efficient, healthier buildings in less time.
The market is looking for solutions that give them the ability to do things faster, do things simpler, and do things with less waste. So from a sustainability, from an energy conservation standpoint, we feel this product delivers to the market what they're asking for.
Research shows that about 20% of all the energy we use as a population goes into commercial buildings. So there's a huge opportunity to reduce our energy load that are going into commercial buildings.
When you look at why we install air barriers, it's for energy, right? So if air can get in, that means cold air can get in, and we have to keep heating the building, or hot air can get in, and we have to keep cooling it. Our HVAC systems are working harder and harder and harder, and we're spending money not only on energy bills, but on the replacement of that equipment. Another thing is moisture. Air can transfer in moisture in the form of vapor very easily. It takes a ride with that air and gets inside a building and causes moisture-related damage. And that's another huge factor why you want to install an air barrier.
Research and development go hand in hand with testing. At both USG and Tremco, they take testing to the extreme.
At Tremco and with USG and facilities like we are at today, we can test for tensile strength, elongation. We can do job-specific testing too. What's great is we've done so much performance testing on this before the product was even launched that so many times I'll be talking with a design professional and they're like, well, did you test that? And I'm like, we did. So what we want to do is bring that confidence to the end user. We're in a lab space today where we have optical microscopes as well as electronic microscopes. They're really important for us in this project as well because we want to be able to get on the microscopic level to understand that consistency of our membrane and the role that it plays.
Today you're going to see a job up in Milwaukee at Marquette University, and it's a great example of how we provided an innovative product and allowed our contractors to finish a high-quality job in a much shorter time frame.
Hi, my name is Todd Moraski, and I am a sales development manager with USG, and we are at the new student housing project at Marquette University in Milwaukee, Wisconsin. We're here with Dan Weiss of Findorf. He's a project manager on this project at Marquette University. Dan, what are we doing here? Where are we?
Right now we're on the 5th floor of the 9-story L building, and we're setting prefabricated wall panels using the SecureRock ExoAir product.
How's the install going?
It's going good. We're on day 3 of 5 right now on the 5th floor, and we're on schedule to finish on day 5. As a construction manager, there are many benefits to using the USG ExoAir product. One being that we can prefabricate wall panels, which ultimately reduces the time that our guys are going to be on the floor setting wall panels versus actually framing on the walls. Another benefit is the USG ExoAir product having a pre-applied air and vapor barrier. We don't have to have someone come out and spray every piece of board in an urban environment. So with prefabricating these wall panels, we can get the walls set faster, which are going to let the glass go in quicker, which is going to let the drywall go on quicker. Just kind of the whole ripple effect that ultimately gets the students to move in sooner. It's really helped increase productivity on the entire schedule and ultimately getting done with the schedule quicker.
I'm actually a Marquette University alum, and I'm very excited that they're using SecureRock ExoAir here on this student housing project because it's going to provide a very high-performing building for many years to come. Our system is revolutionizing and disrupting the air-water barrier industry, and it's great to see customers like Marquette University and Findorf taking advantage of that system and technology.
We know it's going to save not only materials, time, but also waste at a job site. So we know this product is hitting on some of those key sustainability needs that our customers are asking for.
And the research shows that buildings in this country sometimes will have to be in service for 50, 100 years. And you might replace your floor covering or your HVAC system every 15 to 20 years. You're not going to replace your building envelope. It's got to last for the life of the building, which is not decades, it could be as much as a century.
We're that partner. We want to be there as a resource for our customers and be able to provide everything that they need to provide that better building, and that's what our goal is. We want to build better buildings together.
Thank you very much for joining us today at the USG Research Facility and the Marquette University job site. I hope you learned a lot. We'll see you next time.
Well, that does it for this episode of Office Spaces. Join us next time as we continue our search for the most innovative people and ideas in the world of architecture and design.